Okay, that's the timer. Hopefully you have engaged with this, given it a start, given it your best effort. And now I'm going to guide you through to hopefully understanding, going to give Socratic guided questions. And I want you to enter in the Google form so that I can see where you goofing, where you getting it. Question 1. Oh, right. Yeah, the 3 o'clock class. Oh my God. Oh my God. Listen to instructions. When I ask you to identify a force on an object, I want you to always tell me how many things. What's the first kind of thing you should tell me? Type of force. What's the second thing you should tell me? The dealer. The third thing is the feeler. So lots of people, I asked for forces on an object. They said gravity. No! The weight force of the earth acting on the cart or whatever. Okay, so the first thing is, let's talk about directions. The cart moves horizontally, the hanger moves vertically. Duh, right? There's a subtlety here in comparing the acceleration of the cart and acceleration of the hanger we'll get to. We'll have to focus on we'll get to. But tell me about the cart. Does the cart move vertically? Does the cart levitate or phase through the ground? So to vertical forces, what can we say about vertical forces? They're in balance. In the vertical direction, the normal force is supporting the weight force. By the way, two of the forces you should have written down and thought about are, there is a weight force down. There is a normal force up. Did you get that? Everyone? Okay, good. The third force acting on him is what? Tension. Which way does tension point? You can always find the direction of tension by looking at the rope itself. If the rope is horizontal, the tension's horizontal. Ropes suck at pulling, ropes suck at pushing, and ropes suck at turning something, like applying a sideways force. That doesn't really work. The direction of the force on the object is the direction that the rope is leading it away. Okay, so what I would want you to say, no, 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 no. I want to see if you can follow directions, and if this clicks for you. I heard a bunch of people say it, but let's see if everyone. Question A, list all of the important horizontal forces. List them like I'm trying to guide you, to teach you, to beg you to insert it in that format. List all of the horizontal forces acting on the cart. I want you to identify, properly identify every horizontal force acting on the cart.
Understood. Okay.
Okay, getting better, but we're not there yet. What did I just say about weight and normal? They're vertical. What did I ask you to write? Horizontal forces. Think about it for a hot minute. Does the table push the cart along, speeding them along the ground? You take away the other force, just set it on the table. Is the table shoving them along? Is the planet acting sideways? Does gravity pull things sideways? No. Horizontally, the only thing pulling this cart is the string. Second, this is a bit, there are textbooks that tell you, hell, I have from time to time experimented with teaching students this way. There's a thing I don't want you to say, a thing I don't want you to do, a thing I don't want you to think that you will encounter in different places. The hanger doesn't touch the cart. Don't say that the hanger exerts a force on the cart. The hanger doesn't touch the cart, so it does not exert a force on the cart. Say the rope exerts a force on the cart, or the string, or whatever. Okay? It's got to pass through that bubble, through the bubble around it that I will draw. If it exerts a force on it, it has to touch, and that hanger, no touchy, that cart, damn it. Ugh, can't say. Okay? So the correct answer, the one and only correct answer, I didn't even mention this. Friction is small. You can ignore friction for this. Friction is really minimal. Unless you put just a couple of grams of mass on the each object, you can ignore friction for this. Okay, so the only relevant force is tension, and how I properly correctly describe this is the tension of the string on the cart. Bam, done. Don't just say tension. What causes the tension? It's the rope. Oh, also, the other thing is, why do I call this a hanger? Because the word weight sucks. Weight is a precisely defined thing. Weight is the force that gravity exerts, the force that a planet exerts on you gravitationally. So to call the hanging thing a weight, yeah, people do that, but it'll get confusing. Don't call the weight a weight because then, don't call the hanger a weight because then we'll be talking about the weight of the weight and the weight of the cart and the weight of the what. Yeah? Okay. Call it the hanger. Okay, moving on. I want you to identify the forces acting on the hanger fully and correctly. Only vertical forces, I mean, kind of duh here, right? Question B, identify the vertical forces on the hanger. Fully, correctly. Oh my God, you guys are gonna kill me. Listen to how I say to answer the question. The kind of force, normal weight, tension, friction, normal weight, tension, friction. Oh, for God's sake. Normal weight, tension, friction, spring, although we're not doing springs yet. Normal weight, tension, friction, spring, an object that you could lick that exerts that force, and what is feeling that force. Three things for each force. Do not just say, please, do not just say weight. Again, my question for can I repeat, please, is list correctly, properly, with 3 words each, all 3 parts each. What are the forces acting on the hanger? Okay. We need to spend some time on this. This is not working. I've got very few people able to identify the forces and state them correctly. There's a lot of word salad going on. I mean, look, this is new. This is hard, but this part doesn't have to be hard. So let's focus on this. First off, I am seeing so many one-word answers. Let's talk about the cause of a force and the feeler of the force, the dealer and the feeler, the thing which exerts and the thing which feels. Item one, write this down. The cause, the exerter, the dealer, and the feeler, or the thing that is feeling the force or the thing on which the force acts, must be lickable. Two, if there's a force going on between them, if it's not gravity, they must be touching. I had a bunch of people tell me that the table is exerting a force on the hanger. Are they touching? Three, the kind of force. What's normal mean? What exerts normal forces? Two surfaces. Two surfaces exert normal forces. Two solids pressing against each other. For instance, the table supports the cart. The manner of support is a normal force. There is an upward solid-solid interaction, pushing it, keeping it from phasing through and falling into the center of the earth. Yeah. The causer and the feeler must both be lickable objects. And unless we're talking about weight force, they must be in contact. The table, no touchy, the hanger, the table is not a possible force exerter on the hanger. Likewise, the pulley. Lots of people talked about the pulley. The pulley does not touch the hanger. Pulley up here, hanger down there. Different places. They no touch. They don't exert force. Hanger and the pulley do not interact directly. It can't, there is no tension. Hold on. I'm jumping back and forth between two things. I want to focus first on just the causes of the force, being able to identify the dealer and the feeler. There is one more tip that I should have put earlier. The tip is the feeler is always whatever we're talking about. The second word, in the subscript, the feeler is always the object in question. So if I'm talking about forces on the hanger, you don't really even have to think about the second word. The third term, the thing which feels the force, on the is always followed by hanger. If we're talking about forces on the cart, the third word, normal force of the table, on the cart. Whatever we're talking about is the on the. Let's do some examples with this scenario. I'm going to add things to the world, this imaginary world in here, and let's just identify feelers and dealers for each force, okay? So, here we go. This may seem like a nitpick right now, but this will screw you over so hard when we're doing Newton's third law problems, left, right, and center. Newton's third law is if you can't identify the dealer and feeler, you will goof things up. And can't identify that they're not in contact, not exerting force, will screw things up. Here is a physics book. Here is a biology book. It's smaller because biology is worse. Here is a coffee cup. That's not my kind of coffee cup. That's my kind of coffee cup. Here's me. I'm going to tie a rope to box. No, screw it. I'm going to tie a rope to box B because I want to pull biology out of there. I guess I get a little taller. I am pulling on box B. Let's say there's no friction for now. Let's say there's no friction now. No, I don't want to say E. E, I use for Earth as a whole. E, I like to talk about an entire planet is E. I'm going to call this the ground. There's a distinction between the stuff immediately beneath your feet and the entire world, right? This between your feet doesn't gravitate you. It's the entire planet as a whole that gravitates you. And the gravitational effect of the entire planet on you is not what is pressing up against me now. Right? Okay, so I want you to distinguish between ground and earth, even though, yeah, well, I guess technically they're part of the same object. Okay, so coffee cup, biology book, a physics book, the ground, the rope, the earth. Here are plenty of examples, plenty of opportunities for us to practice interacting objects. What I would like you to do now is I'm going to one at a time identify an object, and I want you to put just 2 letters for the kinds of, for not, we're going to skip the kind of force for now, okay? Skip the kind of force. We're just going to talk about each force that acts on each object, the dealer and the feeler. Hint, hint, the feeler is easy. Okay, so I want you to make a list. I'm going to draw a dotted line around an object, or I'm going to indicate an object, and I want you to list every force that acts on them, but just in terms of the dealer and the feeler, okay? Does that make sense? What I'm saying make any sense at all? It would make my life grading, seeing who's getting what and missing what. It would make my life immensely useful if you would alphabetize the list. It's not that long, okay? Yeah, right? Can you do that for me? Okay, give me a comma-separated list of pairs of letters indicating the thing which causes and the thing which feels each force. If you don't alphabetize it, I won't break into your house and kill your dog, but it would be nice if it were, please. Okay, and we're going to start with object A. Object A, forces in C. Forget the kind of force, just focus on the dealer and the feeler. Just give me the letters, don't spell it out. It makes it hard to grade. Oh my God. Okay, so let me give an example here. Let me give an example. I want 2-letter combinations that are going to tell the dealer and the feeler. For instance, if the ground pushes on a physics book, if the ground pushes on A, one of the terms that you would write down is GA. If the coffee cup exerts a downward force, forget the downward. If a coffee cup pushes on A, you would then write CA. The force of the coffee cup on book A. The force of the ground on book A. Then you'd rewrite it because this isn't alphabetized, okay? Just letters and commas, please, okay? Makes it way harder if you words in the middle. Ready, set, go. I'm gonna start with C. We're going to start with object A. Thank you. Object A is in the next to Google Form slot. Google Form C. Yeah. C is the coffee cup, but the coffee cup is going to end up being analyzed in the Google Form. Yeah. On A. If we're talking about A, I don't care forces it exerts. Correct. If I want to find out what happens to my bank account, all I need to do is look at what's going in and coming out of my bank account. Okay, this is what we need to practice. The the forces for the book, book A physics book, I want you to report those in Google Form C. The next Google Form entry. It sucks because you'd think A goes in column A, but we already used him. Yeah. Yes. Hint for the second letter. There should be 2 letters. Oh my God. For each force. Hey, if this is a wildly confusing exercise, could you give me a little more detail about what is confusing? Like, just saying it's confusing doesn't let me know what to clarify. Be a little more specific and I'll help. Getting there. It's getting better. It's not where I want it. Okay, so about a quarter of you are there. Good. The rest of you are violating one of the four rules here. One of the things that I told you. And one more time, we are talking about which box? A. Tell me about what forces are acting on A. You got one more minute. All right, I'm going to call that time's up. There are three pairs of objects. There are three things that interact: BA, EA, and GA. Look, if you forgot the Earth, stop forgetting the Earth. The Earth, the Earth is an important thing. I told you we're near the Earth. You're usually near the Earth, and I'm talking vertical here. Okay? So, rule one from identifying forces, if there's a planet nearby and you care about the vertical direction, don't forget that sucker. Then the second, look at the A. What's touching it? There's a G and there's a B. They are touching it. You just look at what's near it. Look at what's next to it. Those things are in contact with it. My diagram makes it look like they're levitating, but I mean, seriously. Right? Last thing, does C touch A? Does rope touch A? So don't include those. If it doesn't touch, it doesn't force. Oh, and half of y'all told me forces that's A exerts. The second letter is the feeler. The second letter is always the thing we're talking about. If I'm asking about the forces on A, why are you telling me about forces that A exerts? A does not exert forces on itself. A exerts forces on B, on G, blah, 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 blah. So what? Your second letter should always be the thing you are talking about, the thing that you are analyzing. Okay, do it again. Do C. Do C. Put C and D. Let me write that out because the letters being close to each other is hard. Google form D, analyze cup. This is your next task. And check the rules, by the way. We've already got people breaking the laws. Well, this is like 1,000 times better. Good. Not entirely, though. Oh, blast it. And time's up. The correct answers are B, C, E, C. What's touching? Is the table touching? Or ground? Is A touching? No. Also, what did I just say the second letter always represents? It's the feeler is the object we're talking about. If I ask you for the forces on C, C feels the forces, right? On something, if I poke you, you're the feeler. The thing that the force the poke is on is the thing that feels. The second letter is what we're talking about the forces on. So I have a whole bunch of people telling me CB, CE. No, second letter is always what is feeling it. The second letter is always what we're talking about. Do be, and we're going to pretend that there's no friction involved. Screw friction, ignore friction, that gets more complicated. Gesundheit. So Google form E, we double the number of correct answers. See if we can have the number of wrongs again. Analyze book B. Oh my God. You're killing me, Mom. Please turn to your neighbor and check each other. Check that you are following the rules. Sure. That doesn't make it harder for me to see. Okay, we're getting there. We're getting there. It is getting better. We are asymptotically approaching correctness. Learnage. One more time. What's the second letter? Always? The feeler. What does the feeler tell you? The thing the force is on. What is the thing the force is on here? What are we talking about? We're analyzing book what? I care about the forces the book B feels, not the force the book B exerts. So your second letter should be B. Your first letter should not be B in all of these examples. Okay. Second, many of you forgot the rope. It's touching. Look, you may not include the rope if we're talking about vertical forces, but don't forget, just because it's there. It's there. It exists. It's touching. The correct answer was AB, CB, EB, RB. 4 parts, 4 forces. There are 4 forces. They turn to each other and discuss for a second. We're getting righter, but we're not there yet. Okay, you have a chance for questions. I want to do one more and then I'm going to let you guys out early. Really? If you get it right. If you get it right, you get to go. This is just like my lab rules. Huh? I gotta give you a couple more. This is the last scenario. We're not gonna analyze everything. Here's the scenario. I'm driving my baby in a car. This is me, Tucker. This is my baby. His name is Rushan. The car is like everything else. The booster seat, the frame, the wheels, that's all car. Make sense? Everything else in there is the car. And we're on the ground, and the ground is part of the earth, but I want you to distinguish, okay? Yeah? Yeah.
So like, we're considering the speed and all that jazz as like one entity.
Yeah. Everything inside the outline of the car, but human body, is car. Great, we're driving along, we're trucking along, we're zooming, there's a stoplight, we're speeding up, we're really revving the engine. That's utterly irrelevant. Find all of the objects, find all of the dealer-feeler pairs that act on Tucker. This is Google Form F. Everything that's on Tucker in force pair notation. Please follow the rules and follow the notation. I've got a bunch of people typing sentences in here. I want letters, pairs of letters separated by commas. Please follow the directions. Okay. If you said CTET and nothing else, get out of here. You have won. Go fast. Go fast. I love you. Bye. Ciao. Ciao.
Bye.
Okay, get out of here faster. I want to Socratically teach the rest. Oh, you cheaters. Changing the answer afterwards doesn't make it that you got it right the first time. Ciao. Okay, so if you're here, the next most common goof was to put the ground on Tucker. Let's identify which rule does that break. I listed four laws, four principles up here. Which does that break? Yeah.
For example, the car would every force be acting on it because like you are acting on the
Yep.
car, your sun would
Yep.
be the ground,
Yep.
earth, everything.
Yes. Every other thing. Oh, come on. A bunch of fine. Get out of here. You guys are good, but huh? Yeah, exactly. Exactly. I'm just like 30 people got these wrong and you slid out of here. Ugh, cheaters. Oh, yeah, okay, so great. Did you two get it right too? Okay. Yeah. Right. Mm-hmm. Yes. Yes. Please. Nope. Nope. There's no table, hand, round touching it. Oh, you can move. Here, look, I'll make a normal force on my phone. My hand is exerting an upward normal force. Oh, that's in motion. That's in motion. It's moving. My hand is still pressing on it. Yeah. If there were no normal force of road on car, the car would fall into the center of the earth, phasing through solid matter.
So technically, in that sense, the cart, the force, tension force, and the weight force.
Wait, cart?
The cart in the.
Oh, in the previous example. Yes, normal, weight, tension are the three forces that act on the cart.
And then on the hanger, it would just be tension and weight.
You got it.
Okay, I get it.
Ciao.
So there's always technically a normal force if it's like on the ground, right? Then.
Nope, not always. And you don't have to be in contact with the ground. Here's a normal force on a wall.
So.
And if I held onto a helium balloon exactly equal to my weight,
This is like overcomplicating it. Like, because right now I have a normal force right here.
if it's a rope, that's not normal. If the thing is resisting motion in that sliding along something, that's not normal. If it's gravity, it's not normal. Otherwise, it's normal.
Okay.
Two solids touching each other, keeping each other's from phasing through, normal force.
Okay, so for the cart, so if it was being dragged, it would have a friction.
Uh-huh. Yeah.
Okay.
If there's no normal to support it, it would fall through the track. It would break the track. Ciao.
Thank you.
Yeah, good job. I laud you for continuing to think about it. Push for it. Push for it. You're doing great.